All right, well, welcome everyone. I am JJ. Let's tackle an example problem. So in this one, we're saying let's determine the force in members CD and DI, just two members, of our truss shown. And then we're given our support reactions just to help move everything along. So let's tick off the ones we're looking for. Remember, CD goes straight up and down right here. So we'll put a tick mark right on that. That's one of the things we're looking for. Remember, DI goes straight down the middle. So we'll put a tick mark in here. And our last one, we actually don't have a last one. Just these two. So I'm going to come in and try to say, how can I slice through those? Can I cut these two and get all the way across my truss in one slice? And I can do that. If I just go straight across the middle of this, I get a cut that kind of looks like this. I'm also cutting member HI in here. I have to include that as a force in my free body diagram, but it's not going to be one of my answers for everything. But with that slice, I then get the choice. Do I want to circle and go all the way up around the top of my truss, go through A, or go down around the bottom of my truss? I look at which one has more forces. I'd have an AX, a 75, 6, and 9 here. Going down, I would have 18, 54, FX, FY. It's 4 forces either way. And it's the same amount of drawing either way. So it really doesn't matter. I'm going to circle and go up with this. Just an arbitrary choice. So I cut through my roller and come back down and complete my circle. Anything inside those lines is going to stay as a complete member. I'm not cutting it. Its force isn't going to show up in this. The applied loads still come in here and need to be there. But everything down below that is getting cut away, and it doesn't matter for us. That piece is irrelevant for the rest of our problem in here. But I want to come in and try to draw a free body diagram with just this sectioned circle here. So I know I'm going from A down to I. If we just replicate this, we're going from A down to I. We go down and over a little bit, and then we also drop down with that. I have a horizontal member here. At B, there is 75 kilonewtons coming down. 75 kilonewtons. At A, my roller, I'm given AX is 22.5 to the right, so I can put that in, 22.5 kilonewtons. Coming down this, nothing's here at, there is, at J, there's a 6 kilonewtons, going to the left, 6 kilonewtons. If I keep going down, I get down to I and C. I should have a diagonal member connecting these and a horizontal one here. And I'm starting to get to the point where I'm cutting my members at this point. But before I draw them, let's get this 9 kilonewton force in. I'm making that cut somewhere in the middle of my members down here. So that 9 kilonewton is included in here. Going to the left, 9 kilonewtons. And then I get my cut members. At C, coming straight down, we always assume tension on these. I'll put in FCD. At I have one member that goes straight down. That'd be FHI. So straight down, FHI. And going down and to the right, I'd have member FDI. So down and to the right, FDI. And FDI and FCD would intercept down here at point D. We might not have to use that, but that'd be a pretty good place for us to sum moments about because we get one unknown out from it. The other point the two members intercept is up here at point I. Let's go ahead and label those. My dimensions in here for FDI. Well, remember DI goes, our width is 5, so it goes over 5 and up 12. Really, this is a 5, 12, 13 triangle. And we'll let the 13 just be an implied piece to keep it decluttered. My width in here, though, I know this is 5 meters wide. And coming down, that top section from A to J is 3 meters. From J to I is 6 meters. 6 meters. From I down to D is 12 meters. 12 meters. And that's everything I need in here. I have 3 unknowns. I can apply 3 equilibrium equations. I can get through this. So if I were doing this, I would come in and say, there's a lot of valid ways we could do this, but right away, I only have FDI in the x direction. Why don't we go ahead and sum forces in the x and we'll get it. So summing my forces in the x direction. I have my x component of FDI, 5/13 of FDI. I have 9 kilonewtons going to the left, so I'll subtract this one off, minus 9. I have 6 kilonewtons to the left, minus 6. And 22.5 going to the right, plus 22.5 is going to get us to 0. If I solve that one for FDI, we'll get FDI equals negative 19.5 kilonewtons. That's negative when I assume tension in tension. Always on truss members, we should be saying T or C in our answer, but also we should always report as a positive with the correct T or C. A negative in tension is really a positive in compression. So our answer we want to say is 19.5 kilonewtons in compression, which would be our first answer for our problem. With that one known, I still need to find FCD. There's multiple ways I could do that. I could sum moments at D and get FHI, and then some forces in the Y. Or I could just come in and say, if I sum moments here at I get rid of FHI and FDI. I could have done this equation first. And I'll get my FCD out. One equation, one unknown. It's going to be easier than trying to make two equations here. So let's do moments at I. With positive going counterclockwise, I'm going to sum up my moments about point I. Again, at I can eliminate FHI, FDI, and this 9 kilonewton force. All pass through I. My FCD will cause a clockwise rotation, so let's subtract it out. Minus, my distance here is 5, minus 5 FCD. I can also get in here my 6, that will be a counterclockwise rotation, so plus force is 6 times my vertical distance here is also 6. So 6 times 6. My 22.5 will cause a clockwise rotation, so I got to subtract it. Minus 22.5 times my distance is 6 plus 3, 9. And then we'll go to the next row. Our very last one is going to be that 75 will cause a clockwise rotation, so minus 75 times my distance is 5. That's going to get me to 0, equals 0. Which I can solve that for FCD. I'm going to get the FCD is equal to negative 108.3 kilonewtons. That's when we were in tension. That negative, we should probably change our arrows around for both of these, FCD and FDI, to show they're really in compression. So if I did use them again, we'd use the correct direction in there. That dash arrow just recognizes I need to use the dashed arrows direction. But our answer is FCD is 108.3 kilonewtons, and we are in compression, C, which would be our final answer for our problem. Hopefully this is a useful video for you. If it was, hit those like and subscribe buttons. Stick around, watch some more videos. Let's get you in A with JJ.